Drivers behind the line.
Good evening, everyone. Welcome to another episode of Behind the Lines, where we bring the experts to you. I'm Evan Morrison from GameSense, hosting with Naveed Shaffa this week, and we're going to be discussing best practices for the new control system with a couple of experts from our beta teams. This week, we're going to do things a little bit different with our guests. The first 30 minutes is going to be a panel-style discussion, and that's followed by 30 minutes of Q&A with you, the audience.
And before we hand it off to our experts, we do need to mention that the views expressed by Behind the Lines hosts and guests are those of the individual and do not necessarily reflect the views of first or first participants.
Don't forget, you can submit questions to us throughout the show by tweeting at FRCGameSense with hashtag FRCBTL, emailing btl@frcgamesense.com, or by typing !Q in the Twitch chat followed by your question.
With that, we're really excited to have three phenomenal experts with us today, and we'll let them introduce themselves. Over to you, Austin.
Hi, my name is Austin Hsu. I'm a technical mentor on Team 971. I've been on 971 since 2004 when I was a high school student, and we were a C++ beta team. The following video is a clip from we competed in the throwdown competition in Madera, California, and we have a clip of our autonomous mode where we ran both our old competition robot and our beta test robot at the same day in the same match.
All right, next up we've got Jeff.
Hi, I'm Jeff Clements with Team 16 Bomb Squad. I'm a programming controls mentor. I've been with the team since 2010, so about 5 years now. You're about to see a video of our beta testing. We put the new control system on our 2014 robot, and we also did some benchtop testing on our 2013 controls on our 2013 competition robot, which ended up really just being a drive base at the end of the day. So, but here's our 2014 robot.
Very cool, and it looks like you guys even got the lights working.
Oh,
and
couldn't go
everything on
without the
that.
lights.
All right. Next up, we've got Mark. Is he still with us? Did we lose him? All right. Well, while we get Mark back in the call, Mark McLeod's a mentor with Team 358 Hauppauge Robotic Eagles. out of New York. They program in LabVIEW, and yeah, they've got a cool video showing what they did with their beta test. All right. Well, as I mentioned before, we're going to cover a whole bunch of different topics tonight, and it's going to be a little bit of a roundtable panel style discussion. We're going to start off talking with retrofitting onto old robots and backwards compatibility. So, yeah, Austin, why don't you get started? You mentioned that you guys put it onto your 2014 practice robot and then went to a competition with it.
Yeah, thanks, Evan. We were able to retrofit our 2014 practice robot with the Robo Rio and all the associated components, and we're able to get it up functioning, and we're able to compete. A couple things we noticed were that when we were retrofitting the power distribution board, it's a little smaller, which was appreciated since our robot was pretty small. We were also able to remove one of our coprocessors as we switched over.
Cool, and that's actually pretty significant. I want you to go in a little bit of detail about just how much coprocessing power you guys used to have to use in order to get that robot to do what it does.
Yeah, we used to have a beagle bone on our robot that would do all the controls processing and all the logging for our robot. So we would log match data so we could do diagnostics after the match. And we were able to get enough storage on the Robo Rio and enough compute power to move all of that onto the Robo Rio and get rid of the coprocessor, which made our robot a lot simpler and was really awesome.
Awesome. And looks like, Mark, we got you back with us.
I think I'm back.
Yeah, excellent. So
Blue
if you
screen of death.
Oh, no. Well, we recovered. You want to give us a little insight into the retrofit onto old robots, some of the backwards compatibility issues, and your experience with that?
Well, we put the new system on several old robots, and we really have it running around. We had it with the new Victors, and with the pretty running. We had an XY drivetrain that we use with a heavy pneumatic system, and just some regular tank drive robots with arms and slides. And we did the climb from a couple of years ago. The backwards compatibilities, we actually used the slot C-Rios on some of the old robots, and since we were in LabVIEW, we were able to run the new code on the old robot. So that worked pretty well. Didn't have any problems with that. Some of the things were a little odd or a little different because the indexing nowadays is from 0, and the old systems were indexing sort of a different way. But it really wasn't serious. It was just something to be aware of in 1 or 2 calls, function calls.
Cool. Good stuff. Jeff, you got anything to add?
No, just primarily form factor. It fits down in an FRC robot, it seems like a whole lot better. The flat form factor, like Austin brought up, the smaller PDP definitely makes everything nice. The all-in-one pneumatics module, all that worked out really well for us.
Cool. It's actually probably a good segue into our next section. We're going to talk a little bit about the hardware and electrical stuff. If you wanna keep us moving with that, Jeff.
Sure thing. Yeah. So primarily, what I wanted to discuss here is the CAN, the built-in CAN. We were really excited. We've used CAN on every robot since I've been with the team. So the built-in, not having to use the toucan anymore, that's a big deal for us. And it seemed to work out really well. Communication with the Jaguars, we've got that communication working well, and added to that CAN bus now is the pneumatics control module that controls all of the compressors. All the solenoids, and I assume just one compressor. The power distribution panel for all your current monitoring and logging happening there, and the new Talon SRX can run on CAN bus, which we tried out a little bit as well. All that worked quite well. One difference this year in the CAN is it's not tied to the set function calls. It's asynchronous with the RoboRio, so it'll run every 20 milliseconds or 10 milliseconds or whatever it is you define. And one nice thing is, though, they've added some CAN monitoring tools right to the driver's station, and even more to the web dash for the RoboRio. So there's a lot of diagnostics, a lot of checks to make sure you're not overloading the bus. So that's really exciting. All the device addressing, everything is done over the firmware updates. All that's done over the web dash. Really easy to do. Really straightforward. Had no issue with that at all. So we're really excited about the CAN bus on this next year's robot. And I'd encourage teams that haven't used CAN in the past. You're going to get a little taste of it here, and this makes it really dead simple, easy to use.
Awesome. Well, I think we'll move on to some of the other electrical bits. Mark, I know you were talking with us a little bit about the Wiedmuller connectors. If you want to elaborate on that.
Those are the new connectors this year. Instead of you don't have to do any crimped connections or anything; it's just bare wires. The Wiedmuller takes 16 gauge up to about 24 gauge. Depending on the use, you're going to put two sensors would be the higher, the lighter gauges, of course. The heavier gauge one for like a compressor. Compressor plugs directly into a Wiedmuller on the pneumatic solenoid, the pneumatic control module. One of the big things we have is if the wire is fresh and stripped, and you strip it about 8 millimeters, if it's fresh and stripped, it goes in pretty easy. But after you put it in and taken it out a few times, it starts to bunch up, and you run the risk of having a whisker short, where a small wire could connect to the power could connect to ground across it. And it's something to watch out for, because when you're in the pits, the robot will work fine. But when you go out in the field and it starts rattling around, you could get an intermittent short from that, and that's going to be really hard to repeat in the pits and understand what's going on. So watch out for wire whisker shorts on those guys. You don't need any special tools. You could put them in out with a fingernail or with your finger if you want to. Some people tin them. Have been tinning them. Some of the beta teams have been tinning them and putting them in. Other people have been just stripping the bare wire, putting the bare wire in. We haven't experimented with ferrules much. That might be a possibility. Just have to be careful to get ones, because the connectors are so close together. You want to get ones that won't risk a short where the two ferrules will touch each other. How did you guys like the Wiedmullers?
We liked them. They worked pretty well. One thing we found was that with the old crimps, you were able to say your digital sidecar blew out, which is a thing of the past now. But say it did, then you were able to more quickly switch things over. But now it's you trade that for being quicker to put it together the first time. So I like them. And we did find that when you solder the wires, they go in a little better.
You don't have any trouble with them out after you have a risk with them. That's
I didn't quite catch you there, Mark.
the problem we had when we tin the wire, put them in, is they pull out easily sometimes, depending on how you tin it.
Yeah, we actually didn't have that problem. And every time we put one in, we made sure to test it. And we found that generally the problem was when they pulled out was that they hadn't been stripped far enough. So that's just something to be aware of. The data sheet recommends that you strip them about 8 millimeters. And that it seems to be pretty accurate.
Yeah, we also found when you put them in and took them out and put them back in again, they start bunching up and they get shorter than that 8 millimeters. So suddenly they stop holding as well anymore. So you got to be careful.
So one of the next exciting things we have on the table is the brand new motor controllers. Everybody saw Vex releasing those recently, and we happen to have a few people here tonight that got a chance to play with them while they were doing beta testing. And I believe Mark got a chance to work with the Victor SPs, and Jeff got a chance to work with both. Jeff, would you like to talk a little bit about your experience with those and the differentiation between the two?
Sure thing. So we got, like you said, we got a chance to play with both of them. We've got the Victor SPs, and we put them on our drive motor for our swerve drive system. So they were drop-in replacements for Talons on PWM there, and they worked flawlessly without a whole lot of effort. The Victor SPs are PWM only. They're fully sealed up, and the great flexible motor leads on there are really nice to work with. They fit in where they need to go very easily. The Talon SRXs, we did get a couple of those on our shooting mechanism. Those were replacements for CAN Jaguars, and they were a little more work to get up and going, but we've got them working now. And our biggest issue with the Talon SRXs was getting the CAN updates sent quickly. Like I said earlier, the CAN packets are not tied with your set function anymore, so we had to speed that up just to those two controllers because they do need to, they were extremely important that they stopped on time. Once we did that, we had no trouble at all with the Talon SRXs, so we're excited for those as well.
Now, the Talons do actually take PWM as well, correct? Did you try that at all, or did you run them strictly CAN?
We played very briefly benchtop with the PWM until we got the CAN modules working.
Cool stuff. Mark, what was your experience there?
We had them on our XY drivetrain robot and ran it back and forth. They stayed pretty cool. They got warm, but they didn't get hot. We had them mounted on plastic, so they weren't even using the robot as a heat sink, which I imagine we're going to try to do this year, is mount it directly to the metal on the robot and let the whole robot become the heat sink. Pretty easy to switch between coast and brake. Pretty easy to calibrate them. Didn't have any trouble with them.
So one question I have for you guys now is, since the wires are integrated into the system as you get them, how did you deal with terminating those, and if you needed to make any changes without trimming them down too short?
We put one end right into the Wago connectors on the power distribution panel, so you didn't have to worry about that end at all. The other end, we just used a clamp connection that was removable. So we were able to put it on the robot because we kept putting them on, taking it off, putting it on, taking it off. That was the worst part of the beta testing. You always wanted to try something else somewhere else, and we had to take it off and put it back on again later.
How many did you have to work with of each?
We only had 2.
Sure. How about you, Jeff? How did you tackle termination?
So we just use spade connectors like we had been using with our other motor controllers. We enjoyed pulling the screw terminal connections off for the Jaguars, though. We're happy to see those guys go. But we're considering power poles for next season. The Anderson power poles. We think that might be the best option going forward.
Okay, thank you. And one last thing, anything specific for connecting the motor controllers to the PDB? Nothing.
Same as always.
Yeah. Just Wago connectors, same way you used them before.
All right, now I think we'll move on to the VRM and pneumatics control module. Mark, if you'd like to talk about that.
Voltage regulator module takes the place of there's on the old system on the power distribution panel, there was a boosted 12-volt output that we used to plug the radio into. It was 12-volt when they first came out, and then they changed over to 5-volt radios. And then we had to use that 5-volt, 12-volt converter that was attached into the boosted power output for 12, which was kind of strange. They got around that problem this time with the VRM, the voltage regulator module. They gave us a module that does both 5 and 12 volts. So depending on what happens in the future, if somebody comes out with a new bridge that takes 12 volts, we could switch over and it's not much of a problem. Interesting thing we found out about the voltage regulator module is you look at the front of it and it's the two rails, 5 volt and a 12 volt. Both of them, you could put 1.5 amps on either rail. The front of it, though, is labeled 2 amps, but that's a max peak momentary. It's sort of the same way if you look at the D-Link or the back of the Axis camera, you're going to see an amperage on those. That's peak amperage. That's not steady, constant amperage. So basically, you only want to put 1.5 amps on this thing. They're probably going to have it dedicated to the D-Link, or at least the 5-volt side, the rail, dedicated to a D-Link. And if you want additional ones, that you could buy, and you could actually put them right into a Wago connector on the power distribution panel board. So you could have as many as you want. Same thing pretty much with a pneumatic control module. You could actually just plug those right into the Wagos, as long as the rules allow it. We have to wait for the rules. Didn't have much trouble with it. We stress tested a lot. We put too much power into it just to see what would happen. Pretty much it just shuts down. And then you take the too heavy load off of it and it'll come right back again. We did have a problem on the 12-volt side. If you try to put 2 amps in that, it took us about 4.5 minutes to blow the module out on that one. So don't do that.
Do you have a recommendation for how teams would avoid doing that?
Just use it as it's recommended to be used, probably. Really, the 12-volt side is only a danger if you're going to do something like LED lights or an external processor. Just be aware of how much wattage you're going to pull out of the thing and make sure it's capable of handling it.
Cool. Thanks, Mark. So I guess
one thing I'll note there, that is your only source of regulated power now. Like Mark said, you used to have some regulated power coming out directly out of the power distribution. If you need any regulated power, it needs to come out of the VRM now.
All right, thanks, Jeff. And now, Austin, we'd like to talk to you about something that you've been interested in, brownout. This has been something that people have been talking about, especially with the hype behind 6-sim drives. If you'd like to talk about voltage drop here, that'd be great.
Yeah, thanks, Naveed. So the new controller has new brownout characteristics that I think are worth understanding. So it has a couple stages of brownout. So at about 7 to 7.3 volts, you start to lose PWMs. So at this point in time, the RoboRio, when you're driving the robot hard, the RoboRio turns off all the motor controllers explicitly, including the CAN motor controllers, in an attempt to prevent itself from dying. And as the voltage continues to drop, and you get about 6.4 volts, then the power supply for your sensors starts to drop out. And then as you go from there, at about 4 to 4.5 volts, the RoboRio itself shuts down. And then at about 3.5 volts, the D-Link drops out and the voltage regulator module. So I think these numbers are worth understanding, and I hope teams don't run into them too much. One thing that beta teams found was that when the 6-sim robots tended to hit the brownout conditions more than the 4-sim robots. So I think that's going to be interesting this year to see how teams deal with that and how many teams run into this issue.
And did you get a chance to see how long it would take to come back after that?
Yeah, so we, as I said before, we have a lot of logging on 971's robots. So we logged if our motors were browned out every 100 times a second for all of the matches that we played, and we found that our average brownout time was under 1/10 of a second. So it recovered pretty quickly,
Oh, wow.
which was really, really comforting.
That's good, but it obviously has the ability, if it happens at the wrong time, to mess something up with a part of the robot. So teams definitely want to be aware of that.
Yes.
Did
Cool.
you notice any of that at Madeira?
It happened. I mean, we have logs from Madeira, and we saw it happen. But I don't remember a point when I was on the field when I saw the robot in a state that looked like it was browned out. So my driver didn't come back and tell me that he believed the robot was browning out as well. So I think that's a good sign. I think part of the reason that we didn't see more brownout conditions was because we only had a 4-sim drivetrain.
It's good to know. All right, well, we're going to move on from the electrical and the hardware to the software side real quick, just before we take some audience questions here. So we're going to stick with you, Austin. Programming languages. We've got some updates here, and we'll pass it around a little bit, but if you get us started on that.
Yeah, it's pretty exciting, the new control system. So we're finally to a modern C++. We're up from GCC 3.4.4 to GCC 4.9, which is a huge jump. So we get C++ 11 and C++ 14 with all the nice features that come with those languages. Jeff, do you want to talk about your Java updates?
We're a C++ team, actually, also.
Sorry, Jeff.
So, yeah, we had a similar experience. One thing I'll note about the C++ and programming in general, it is very backwards compatible, like we did bring up. But do make note of any get raw access or calls to channels, because they are all 0 indexed now instead of 1 indexed. But check your driver station, because you do have a lot of that information on the driver station now about what axis is moving, what buttons are being pressed. A lot of that information is in there, handy.
The Java
Mark,
is.
how about
I'll do LabVIEW and Java. I'll touch both.
all right, how about that?
The LabVIEW is 2014. They've been National Instruments has been doing an incremental increase every year, so it's always been LabVIEW 20. We were using LabVIEW 2013 last year and 2012 the year before. There aren't any major changes in LabVIEW 2014. They fixed a few bugs and that kind of thing. Nothing the teams are going to really notice. There are a couple of changes to the VI's calls. Things primarily, for instance, the joystick get axis is now indexed, so it's not named like it used to be called axis 1, axis 2. Now it's just an index, or an array that's indexed, and it's 0, 1 through whatever. Java had a big upgrade. It went from the old runtime engine 1.3 up to Java 8 this year. So it's no longer under that Squawk Micro Edition thing that they used to run. And you could do lambda expressions, you could do enums, all the stuff you could do in the modern language. They're all available to you now. So that's kind of nice.
Hey, Mark, would you like to touch on the MDNS a little bit more before we move on to the Q&A? Perhaps
sure.
indexing?
The old way of doing things is we all use static IPs, like on our driver stations and everything. Now it's going to be MDNS based, where everything stays at DHCP. So your driver station no longer has to be changed over to a particular IP address. It just has to be able to accept a DHCP address. First is given in the software they've distributed to us, or will distribute to us on kickoff day. They're going to give you a special setup tool, as they usually do, for the D-Link, and it's going to set the D-Link up to serve addresses DHCP to these devices. So the RoboRIO is going to pick up an IP address from it, and the driver station will pick up any programming laptops, whatever you want to add to it is going to pick up an address. They reserved a block at the low end where it used to be from like .2 to .19 that you could use for static IP addresses if you feel like it. Like we were running 2 or 3 cameras, and so we set static IP addresses so we could tell them apart. And that still works fine, so you can still do that. But it should be a lot easier when you get out to the field to play, especially if you have like a school laptop where they don't let you play with the IP addresses all the time. They're usually set up for DHCP, and those should work out of the box, hopefully. We'll find out.
Excellent.
Thanks, Mark.
Okay, so we're gonna move on to our audience Q&A. We got a lot of really good questions. We'll try and get through as many as we can in the time we have left. So the first question that we've got is we're gonna start with you, Jeff. Can you talk about some of the features of the web dash?
Sure thing. Primarily, so to get to the web dash, you go to RoboRio dash team number in any browser, and you can get to it, or put in the static IP address of the RoboRio, and on there you can update the firmware for the RoboRio itself. You can see all the CAN attached devices, so all the Jaguars, the PDP, the PCM, and Talons that are on CAN. You can address those CAN devices. You can update the firmware on those CAN devices. You can get a whole lot of information about the devices themselves, the throttle, the setup of them, all that good information about CAN that I'm so excited about. There's a lot of other features on there. I'll throw it out to the other two guys. What they might have gotten use out of the web dash.
Well, you have to use it there are sticky faults on some of the devices, the power distribution panel and the pneumatic control module. They have sticky faults. For instance, if the battery voltage drops too low, like we're talking about during a brownout, if it drops below about 6.5, you're going to get a yellow blinking light on the power distribution panel. That's persistent. That's sticky. So they're going to turn the robot off. They're going to take it back to the pit. They're going to turn the robot on. It's still going to be yellow and blinking at you. You're going to have to use the web dash to clear that fault so it goes back green again so you could tell later on. You could also do it in code. For instance, we set it up. There's a user button on the RoboRio that you can do whatever you want to with. We had that set up to automatically clear the faults because we were faulting constantly in beta testing.
All right, thanks, Mark. Question number 2 of the evening is, has the FRC programming API changed a lot for each of the languages, or are the differences in the actual software to implement minuscule?
LabVIEW, there was like 1 or 2 changes. You know, they were very minor.
Anything with WPI lib?
Some of the
big
function
changes-
names changed, right? Go ahead, Austin.
The biggest change in WPI Lib was the change from 1-based indexing, so your first sensor being sensor 1 to being
Right, to
sensor 0.
Yeah.
So that's the biggest one that we noticed. Jeff, what was your experience?
Not a whole lot beyond that. Just follow the numbers that are on the RoboRio for the channel is the biggest part of it. If you follow what you're plugged into, you're in good shape.
Great. Thanks, guys.
Excellent. All right, so I think our next question, and I'm gonna kind of throw it out to all of you guys and see who wants to give input. To what extent can onboard vision be done before we start seeing clock skew or processes running slow on the FPGA? Has anybody done any of the vision stuff or just intensive?
Well, technically, the FPGA won't ever be impacted by the vision stuff, since it has nothing at all to do with the vision stuff. So the question is a little odd. We had a couple of cameras running. We did the vision target stuff from last year. We didn't have any trouble with it, but I wouldn't consider that real intensive use. I don't know. What did you guys have?
We had a lot of processes running on our RoboRio. So our code's broken up into about 10 processes that communicate. And what we focus on is making sure the priorities are right for all the processes. So our control loops have really high priority, so they will run before everything else. And our logging, for example, runs at really low priority. So since it's a modern real-time operating system, you can run it pretty much at 100% capacity. You just need to get all your priorities right. So your vision is lower priority than the rest of your code.
Jeff, you got anything to add, or?
We didn't do any vision processing. We're pretty easy on the RoboRio.
Good stuff.
Got another question about the RoboRio next. Will you be able to use third-party libraries like OpenCV on the RoboRio? If so, how would you install them? And did any of you guys work with OpenCV?
I know WPI Live, the WPI guys have an OpenCV installation, and also I think Aluminum Falcons in Connecticut have their own OpenCV that they're playing with as well. So it doesn't sound like it's any trouble. I didn't play with OpenCV. I used NI Vision myself.
Well, I guess we could play off of that. What was your experience with NI Vision on the new controller?
Well, since it's a National Instruments hardware and it's National Instruments software, they worked really well together.
That's always good to hear.
Not that you'd have any bias.
We're actually probably going to use Java this year.
So the RoboRio has a little package manager on it called OPKG. So if you connect your RoboRio up to the internet, you can actually download a couple extra packages. And I don't know if OpenCV is in those, but it's a pretty cool feature if you want to add some more commands without having to build them for it from scratch.
And you can pretty much install your own packages, whatever you want to experiment with, really. There's no limitation there.
Yep.
Cool. All right, here we go. So our next question is, and we'll hit everybody with this one. What's the best upgrade from the C-Rio in your opinion? So Jeff, why don't we start with you and we'll go around.
I'll throw it as a toss-up between a couple of things I mentioned already, but the form factor is hands down better than the C-Rio. Being able to be flat and slide into a lot of places that the C-Rio never could have been mounted makes a big difference. That's in a tie with built-in CAN. We are excited about that feature on the RoboRio.
How about you, Austin? What was your favorite thing?
My favorite thing was that it's running a modern operating system. So we're able to log in and do a lot of work on the RoboRio, which you couldn't have done before. That was really exciting for us. We made a lot of use of that.
Mark, you want to weigh in before we move on?
Yeah, it's about 2 pounds lighter, the whole system. I like the lightweight because we're going to use the 2 pounds someplace else. It'll be 2 pounds over maybe. I like the simpler. I think the most of the electrical connections are simpler because they're all either Wagos or Wade-Muller connectors, rather than the odd mixture we had with breakout boards and various types. These voltages that were going around the system. So I like that.
All right, next up, has sensor integration been easier, harder, the same as before? How about PID and current control? Austin, you want to start off?
Sure. So the sensor interface is pretty much the same as in previous years to WPI Lab. So it hasn't really gotten harder or simpler. One of the really cool features on the power distribution board, though, is that we have per port current sensing. So you can go monitor all your various controllers and see which ones are drawing a lot of current or not very much current. And that should be very useful.
I'll tag on with this a little bit, kind of add on a question here. Jeff, did you get a chance to try any of the built-in PID features of the Talons when you played with them? I know I'm kind of putting you on the spot here.
Unfortunately, no, we haven't been able to get there just yet. Our swerve modules, I was really pumped to try it out on there, but they use a 5-volt output, and it's a 3.3 volt input to the analog in on the CAN Talon. So it wasn't just a drop-in replacement for that PID control. So we're still doing that in the RoboRio like we were before with the C-Rio. So it's still something we're considering, and I think we want to use it next year for our PID control for our modules, but we haven't had a chance to do this yet. We plan to before the year's out.
How about you, Mark? Sensor integration, easier, harder, about the same?
I thought it was a little bit easier to use the I2C and the SPI buses than it was in the past. I like the how everything worked together a little bit easier. We were running a couple of gyros. We ran a couple of additional accelerometers, including the built-in one. And we just, what other devices we just had lying around pretty much. It didn't have any trouble with integrating them. They pretty much plugged and played for the most part.
All right. So our next question is on CAN, so it's going back to you, Jeff. Do you have a suggested baud rate for CAN to transmit to the controllers?
So baud rate is set by the controllers in the RoboRio itself. That so that the baud rate isn't settable, but the frequency of the frames that are sent is. The Jaguar by default is updated every 20 milliseconds. The CAN Talon is updated every 10. The two that we on our shooter motors that we wanted to have very fast control over, we set at 2 milliseconds. But we just set those two. We've got 6 other controllers on the bus, and we were able to stay under 50% utilization on the CAN bus. So if you keep it down, if you don't go overboard trying to make those super fast, then you shouldn't have any trouble.
Yeah, we had a chain of about 17 devices on Canon, just using percent voltage on some Jaguars. We didn't have the Talons, unfortunately, but just on the Jaguars, we used only about 20% of the utilization, but we weren't doing a lot of statuses and changes.
Cool. So I think our next question is on custom circuitry. We're going to go to Austin with this one. How do I program? Yeah, how do you program for the custom I/O pins?
So I'm assuming this question is about the MXP port. And we actually went and had a little board fabricated and assembled it. And we're able to break out all the digital and analog inputs on the MXP port and use those. And it was seamless. So it just keeps the ones that are built into the RoboRio go from 0 to 9. And the digital inputs on the MXP port just start counting at 10 and keep going. So we were able to use those quite well.
Excellent. Jeff, Mark, did either of you guys play with any of the custom I/O options?
We did the communications. We did the I2C and the SPI and the TTL on that one, and did some PWMs and DIOs, but we just made sure they worked, basically.
Yeah, we used one of the analog ends. We did that by scavenging a cable out of an old hard drive. And just wiring the pins up directly because we didn't have a good board to work with back in the alpha days, and it worked fine. So whatever it takes to make it work.
We were able to feed 10 digital sensors and 5 encoders into the RoboRio. So that's what we needed to get our robot working.
That's awesome.
So the next question comes to computing power. Since we've got a much heftier system to work with, can you guys actually run new processes on the second thread as well?
Well, LabVIEW is multi-threaded to begin with, so it's really hard to say. I'm probably running about 20 or 30 threads at a time.
How about you guys with C++? Was there any noticeable changes there?
We're using a lot less CPU than we used to. That's one thing I noticed. And our robot code was multi-threaded, so it definitely should use both cores.
Yeah, I'm sure both cores are used, but I didn't see any way in the API to be able to specify which core taking advantage of.
There is actually a resource I just remembered that we'll link after the show that Team 488 XBot did, and they actually did computations on change in speed using multiple cores.
Very cool. All right. Go ahead.
If you want to use the second core, you just need to spawn up another thread. You can use WPI's task interface or the Linux pthreads implementation. And if you really care, you can bind it to specific cores with the Linux API, if you really want to go overboard. It's a lot easier just to let the kernel take care of it for you.
Okay. Only got time for a couple more questions here, so we'll wind it down a little bit. And I'm going to throw this out to everybody. Have you done any closed-loop current monitoring on the drivetrain? Has anybody played with any of the current monitoring on individual ports for control loops at all? Do you have any experiences with that?
We did until we burned out the CAN bus on the PDP. Yeah.
How'd you do that?
Well, we've been taking it around to different teams so they could wire it and everything. Somebody wired power into the CAN bus. Doesn't work real well.
But you had a positive experience using the current monitoring.
Yeah, you just have to be aware of the update rates about 25 milliseconds. You just have to be aware of the lag that induces. That's all.
Cool. All right, I think it's time for our last question, and then we'll wrap things up.
So last question would be, what has been your favorite part of the beta test process, and do you have any memorable experiences you'd like to share?
I'll take off. How about that? I'll jump back to alpha testing. We were an alpha team as well, and we got to go up to Manchester to have some simulate a field and the conditions around that, and that was a blast to be able to see all the other top-notch first teams and to work directly with the WPI and National Instruments and all those guys. It was a lot of fun and a great experience.
How about you, Austin?
One of my favorite parts was figuring out how to move everything over from our coprocessor, the RoboRio, and it was surprising once we figured out how to interface with all the sensors how well it actually worked. That was fun. And the favorite part was being able to help fix all the bugs and help make it work better for a lot of teams. That's fun to be a part of.
And Mark?
I enjoyed stress testing for some reason. I enjoy stress testing. I like burning things up when they don't have to pay for them. So that's really nice.
Well, we appreciate somebody getting to do that. Save the rest of us some headache and some heartache. So we're kind of going to end with another blanket question, but overall impressions of the new control system. Just to wrap things up, any last words, pieces of advice, what have you? Mark, we'll kick it back to you and go reverse order here.
Read all the documentation. People don't read documentation. Read all the documentation this year. We spent a lot of time on it as beta teams, helping bring it up to speed.
Austin?
Yeah, it's a little different, so I'd recommend getting it up on a robot and start playing with it as soon as you can. Yeah, you put it on an old robot at the beginning of the season while you're designing your new one, learn how it works.
Or I'd say even benchtop. That's a great place to learn, is just put it on a benchtop, screw it down to some wood or whatever you've got around and just play and go through the getting started with the control system on the screen steps. Even if you're a veteran team, you've been around this 100 times. There's a lot to learn out there, a lot to use on the new control system. So we're excited.
Thanks, Jeff. And thanks all of you guys for joining us tonight. We really appreciate having you guys on here to talk a little bit about your experience and answer some questions from our viewers. It was a lot of fun, and we're glad you could make it.
Happy to be here.
Thanks for having us.
Thanks for having us.
Well, that does it for tonight's show. We have one more Behind the Lines episode for this run, and that's going to be after kickoff. Stay tuned for that shortly, but we're going to be talking about the kit of parts and some of the cool software tools that come as part of the virtual kit of parts. Really excited about that, and looking forward to a great season. On behalf of all of us here at GameSense, thanks for tuning in, and have a good night.